Hello everyone, my name is Deiners Galvis, and in this video I'm going to present the results of my experiment on a projectile motion using the PHAT projectile motion simulator. In this activity I explore how changing the launch angle, the initial speed, also the height affect the trajectory and the maximum height on the horizontal range. To start, I configured the simulator with different settings. I test angles from 70 to 85 degrees, moving down and up the barrel of the cannon. Also, the initial speed was set and tested from 15 to 24. The maximum test was 24 meters per second, and the height was established until 7 meters height of the position of the cannon. I also changed the mast and the diameter of the cannonball. And I noticed something interesting when the air resistance was turned off. Uh, those two variables didn't affect the trajectory at all. But when I turned the air resistance on, the projectile slowed down much faster, and its range became notable. It was noticed that it was considerably very short. For each case, I record the maximum height, the flight time, and total range to see how it changes the influence of the motion. As an example, if I test the cannon uh, with 77 degrees in a position of 7 meters height with an initial speed 24 meters per second, a mass of 17.60 kilograms with a diameter of 18 meters, 0.18 meters. The gravity, it was just the standard. And when I shoot the cannon, we can see the trajectory of the cannonball, which is very long. So when I use the meter, which is here, I can establish how long was the distance of the trajectory. When I put the air resistance and I shoot the second one, which is in the purple, we can notice that it's shorter a little bit more. So if the mass and the diameter is increased considerable, the resistance of the air is going to produce uh, even a shorter distance for the cannonball. During this experiment, several questions came up. How does the angle affect the range? What happens when I change the initial speed? And how does the air resistance modify the motion? For those questions, I propose two hypotheses. The first one, if the launch angle is 45 degrees, the projectile will be the maximum. So to test this one, I just set it here to 45 degrees. Sorry, 45 degrees. I'm gonna put shorter the initial speed in order to see the long movement of the ball. And when I shoot it, we can notice basically this is the trajectory. Now, if I remove the air resistance and also the diameter, and when I shoot it, this distance is going to increase. The second hypothesis, if the initial speed increases, the projectile will reach a higher altitude and a longer distance. So with the same angle, but with the maximum, which as I told you at the beginning, it was just the 24 meters per second. So the distance is increased notable. Our idea is based on the mathematical model for projectile motion, where the trajectory depends mainly on the angle of the distance and the initial speed of the cannon. To verify this hypothesis, we can use basically, which is the mathematical model of projectile motion without air resistance. So the equation for this one is this one that I show in the screen, which is basically the basic mathematic to check this information. These formulas describe the position of the trajectory over time. Using them, I calculate the maximum height, flight time, and range for different launch conditions. Then I simulated the motion using Google Colab with Python and compared the results to the PHAT simulator. The outcomes were very close, showing that theoretical model match realistic really quite well when air resistance is ignored. However, when I activate air resistance, as I show you, the results change notable. So again, once again, if I put the air resistance with the same conditions and I shoot it, this is going to be reduced. And if this is even more when I increase just the diameter. I don't need to increase the mass because this is going to be probably for the causes of the weight. But in this case, it's just the diameter and the resistance with the air. The two hypotheses were confirmed. An angle of 45 degrees produces the maximum range only under ideal, no air conditions. And increasing the initial speed clearly increases both height and distance. This experiment showed how theoretical models and digital simulation complement each other, helping us better to understand how objects move over the influence of gravity on air. So thank you very much for watching.